Hi everyone, my name is George, and today I want to present to you my talk, which is Zero Knowledge Applications on Mina. Yeah. I represent A1 Labs. We are a blockchain technology company. Initially, we created and launched the Mina protocol, and our mission and vision is that we are dedicated to providing Web3 with FSM solutions that we want to that we're dedicated to catalyzing a new generation of applications. Sorry, I cannot do it on the doc. But yeah, we do a few more things apart from working on Mina, which is O1JS, which I briefly cover over this talk. And also we work on an optimism in a way. So they ask for, they publish their request for proposals. We answer it, and we adapted our cryptography stack for their use case to, as a proposal to strengthen their security, which is super interesting. Just in case not all of you saw this project before, I will just briefly talk what is Mina. So first of all, it's one of the world's lightest blockchain. It is just necessary like a few kilobytes of data to verify the whole history of blockchain from the very first transactions that happen on it. No one is full nodes do not need to keep history on them to verify consensus. That also means that verifying the blockchain state doesn't require a whole lot of hardware resources. It can be done on phone, it can be done in the web browser, on any laptop, definitely. Our design, our cryptographic design doesn't involve any sort of trusted setup. The network is pretty well decentralized, and the most interesting thing is that very soon, we'll have zero knowledge applications to be that you will be able to deploy on the network. So, just a few more words about the distinction here. So you all probably are familiar with the architecture of Ethereum-style networks. You have a user submitting transaction to the network, and you have a network of nodes. Each node takes this transaction and it runs this transaction. And this way, network confirms that transaction is valid to itself. So in Mina, it's completely different. User comes up with their transaction, but they do not send transaction like a program out there. What they actually do is that they compute a proof locally, and they only send the proof of this transaction to the network. And then Mina nodes in the Mina network are not busy rerunning the whole transaction, like in some other blockchains, but they are only verifying the proof. Not even all of the nodes have to verify the proof, but not a single node is rerunning the transaction. This is the diagram of what I just said, but one more thing here is that we combine a few transaction proofs into a block, but then we combine this fresh block with the proof of the previous block, and this way we have the block proof for our new block. And what is, this is just a silly diagram, but what is an interesting thing here is that the size of the previous block proof and the size of the block proof for our new block are the same. Time to verify these block proofs are the same. So you can have millions of blocks, but the proof size will be the same. And you will be able to check that the account in the latest state of the blockchain, that is coming from directly from Genesis after so many blocks, it is the same, and it is the same that you expect it to be, and you only need this proof, this one proof. So where we are at having this, Mina mainnet is live for more than 3 years. However, it only has payments. So we are anxious, not anxious, we are super excited. We are anxious too about it. About launching the caps basically in weeks from now. Because just last week on Tuesday we launched testnet, which is our final testnet, which always replicated very closely what we have on the mainnet. And now it is different. Now we hard fork this testnet, and we are going to repeat this hard fork procedure just the same way on mainnet really soon. So so ZK apps will soon be out there on mainnet. So let's talk about what they are. Before going that, I just wanted to make sure that we're on the same page here. First, the question is, what is zero knowledge? What is what it is for? Like a textbook example. Say you live in some small, super digitalized country, and you don't like something in your neighborhood, and you want to sign a petition and send this petition to your local representative. But because it's a small community, you don't want your local representative to actually know that it was you who submitted this petition for maybe personal reasons or whatever. Now it's probably it can be achieved now organizationally, but a novel approach would be to use zero-knowledge cryptography for that. In this way, you would have some website, you would have your, say, passport. Everyone's passport has, electronic chips with some hashes and signatures involved in creating the chip. So you would be able to log into a government website, use your passport to proceed with verification, sign a petition, and this petition would go to some, petition registry of your country, Not a single person, except for yourself, would know that you created the petition. They would still know that you have a passport of this country, you're registered in the district related to this petition, but no one will know your identity. So I think this will be a useful application one day. Now I changed topic completely and want to talk about what is ZK apps finally. A few design considerations that we took for developing this technology. First, imagine that you can develop these smart contracts involving some private data which you don't want to reveal, but you still do it in a conventional language. In this case, you want to do it in TypeScript. Choice of TypeScript is not random. We still think that many applications in Web3 will be in the browser, at least as one mode of operation. TypeScript is a browser language of choice, after all. You want your ZK apps to seamlessly handle private data. But for example, to develop even that use case from the previous slide with Passport, you still need many tools at your disposal, for example, to verify the passport identity from the passport, you probably need some signature verification, and that signature is not readily available when you write a zero-knowledge program. You want this to be usable. You want someone else to have used it before you did, because they would find all of the troubles using it before you. And you may want to execute it, in your application, not involving any blockchain, or using Mina on the blockchain. So combining all of this is ZK apps. Going back to this example, we can kind of split this talk into equal parts. The first part will involve ONJS, which is our TypeScript framework for writing smart contracts, these zero-knowledge applications. The second part will briefly mention how we incorporated these ONJS programs into Mina blockchain. And here it is on the example. You use ONJS in your website application run by government to make a proof of the petition signature. And then you send this proof and petition hash maybe to registry, which can be run on Mina blockchain. So, but before going to that, one really technical distinction which still makes our project stand out from many other projects in the ZK space. We don't use the KVM. We don't have any kind of VM built in. We have ONJS to compile zero-knowledge programs directly to circuits. You can compare it similarly to that you have languages like Java that compile to some bytecode that is being run by VM, or you can have Go, which compiles directly to processor instructions. For the end users, it most of the time doesn't matter much, but it's just a very curious technical choice. And honestly, I am very curious to see how it worked out for other teams who chose different approach. But like we have our circuits, and it's also very interesting how far we go with this approach. So, but let's talk about some details, and let's meet O1.js finally. So, first of all, O1.js is a TypeScript SDK. So you write programs in TypeScript. You can reuse all of the development tools that exist for TypeScript. So basically, it's a set of libraries for TypeScript. Yeah, here is some example of a very simple smart contract. So this smart contract, it just has one field, which contains just some number, and it has just a single method which allows you to update this number. But like some details about this very simple program, which doesn't make sense at all to be deployed in any production whatsoever, but some details are actually interesting. For example, this method has x as input, and this x is actually a private input. It doesn't make sense in this application because you can subtract previous state from your current state and guess this number. But say if in this update method you would say take a hash of addition or something like that, then it would make a lot of sense for x to be private. And in fact, every method parameter in the smart contract written in O1.js by default is private. So yeah, like this was. This is just a simple program, but you can see here that yeah, it's pretty readable, and it's just TypeScript. So like after you write this program on TypeScript, you still need a few things to happen. We have a proof system called Kimchi, which like employs interesting cryptography, really interesting, to like you take your program and generate like a pair of proving and verification key, which you can actually use to verify proof of execution of your zero knowledge program. Kimchi was developed like a few years ago, like in more or less the same, like it's more or less the same thing as it was like a year ago, certainly. And we have like a lot of useful toolkit in it, like Poseidon hash is just, naturally happens there, but also you can have foreign fields which allow you to have some, elliptic curve conventional signatures. So we have a lot of stuff there, but also we have like Pickles, which is even more interesting because it's a recursion protocol, and every smart contract written, like every ZK apps, every smart contract written in Mina will be able to use naturally this recursion, and Pickles is actually in Mina since the mainnet launch. So yeah, it was kind of battle tested a little bit, maybe not. Yeah. We have like rich standard library. We also took care of a few things that you really want to have when you're writing Mina smart contract. I mean, when you're writing not just a ZK program that is run elsewhere, but that is run on blockchain, which is section reducers and event. Like it's somewhat similar to sequencer that guys mentioned in the previous ZK talk in this room. But like it's kind of natural thing to come up with zero knowledge applications on blockchain. Yeah, and we also have a very nice way to express recursive programs. So what is recursive program? Basically, it's any program that goes in steps, one step after other. Like you have some initial, data, then you take some input from the user, you run your program against this input, and you have the new data, and you repeat this many, many times. So like this multi-step program in ZK parlance for certain reasons it's always referred to as recursion, and we have a very natural way to express recursion in O1.js. You specify what your state initially was, like base case, and you specify how will you transition from the initial case to the new data. Or not from initial case, but from any previous data to the new data. So this is example of Fibonacci sequence verification. It's a broken example because we need at least one more condition. But yeah, anyway, it still fits on the slides. That's why I omitted that condition. So, and just a few more words about, so previous talk was all about OpenJS. You have some TypeScript that generates like a pair of verification key and a proving key, and that's it. You can deploy it, well, you can embed this verification key into your exe file, deploy it to users as Windows executable, and make this Windows executable talk to, say, a Telegram network to get a new proofs to verify. It doesn't need to involve blockchains, that's what I mean. But in our case, we use OpenJS programs to embed them in our Mina blockchain. So how does it happen behind the scenes, this integration of OpenJS programs into Mina? So yeah, I would like to compare it a little, like, so I would like to compare ZK apps to electric vehicles. So, like as some of you probably know, like electric vehicle motor is actually much simpler than internal combustion engine motor that is in most cars to this day. However, there is a very tricky part to put a lot of energy in a small battery. That's why, like, we didn't have electric vehicles until very recently. But it turns out that if you manage to have this battery to hold a lot of energy, like the rest of the stuff in the car is much simpler than in case of internal combustion engine car. And the same thing applies to here. Like the cryptography proof system, it's really complex. It's not easy to come up with. It builds on years of cryptographic research that came out just years ago, not decades ago, like with some other stuff. But after you manage to that proof system, like this handling of transactions in blockchain became much simpler than in many other blockchains. So just what we keep as an account on the blockchain, this is a definitive list. So you have 8 32-byte values, which are like on-chain storage. Honestly, you could go even with 1, but 8 is just for convenience of app developers. You have verification key, just OpenJS gives you after you compile this program, and it allows you to verify any transactions to this that is coming against this ZK app. You have like some permissions thing to be able to control who and how can use your ZK app. This is partially for convenience, partially for enabling more use cases in a simpler way, and actually a few more things. But all of these fields, except for the first one, are just a few bytes of data being stored on chain for this account. It's really simple, and yeah, such a simple structure of account state allows us to have transactions that are also very simple. Like there is some fee payment data in transaction. There are like preconditions are like something like, oh, this transaction cannot be executed after this time, after this date, and there are updates to account fields that I showed you on the previous slide. Also, there is of course a proof for each account update, and there are up to 9 account updates that can be packed into a transaction. But that's it. We don't have, because we don't have like function calling as in Ethereum on our blockchain. We don't have API, for example, which will encode all of these, all of the, you know, function parameters that you need to use to call your function on your blockchain. All of this complexity is, you know, it's just absent. We just have a verification key, and we just need one proof. Like every transaction is of the same size, basically. So yeah, and just a few remarks of why it's so simple. You can pack any amount of data into this 8 fields, 8 large numbers, by using hashing. And when user assembles this transaction to the ZK app, user makes a proof for it, so you don't have to handle a lot of proving in, like we still have to handle some proving in the network, but at least it's independent of the size of contracts that users deploy. And so for that reason, we don't have gas system or anything like that. Yeah, like, and we have a bunch of interesting technical solutions that allow to express a lot with a very simple abstractions underneath. So, and just a few more words about my personal favorite topic, which is how the network stack is organized. So it's also simpler. You don't need to download the history of blockchain. and you just need a few headers, a few chunks of data, each is 8 kilobytes. Like totally it's way less than 1 megabyte of data that you need to download to verify at any moment any like state of any account, like balance of any account or any data that is stored in that account. At any moment you were just never ever opened your laptop. You just open your laptop, you download the Mina executable, and you need just to download 1 megabyte of data on top of that to verify the state of account. And yeah, this verification can run in browser, and actually it is run in browser already. Yeah, and just a few words about what's next. So first, mainnet release is next. And after that, we have a lot of things in the works. Like we work on some cryptographic features, which enable some cool use cases like the KML, but also that optimize existing use cases to make proving faster. And we use we work on a bunch of usability features like off-chain storage. Actually, Gabi is present here, who represents the team that works on the KRL calls. It's a separate team from O1 Labs, but they also are part of Mina ecosystem. Yeah, and just last two highlights in this presentation. Currently, it's possible to prove anything any state of the blockchain in the browser, but it requires info-like service. So we really want to get rid of this necessity and make the browser node like first class. You directly communicate to the network, and you can prove anything just the same way that full nodes do. Integration with Ethereum is also a work in progress, which would allow one day that any Ethereum contract will be able to reference any data, any transactions that happened on Mina blockchain without any effort from the writer of this smart contract on Ethereum. So thanks a lot for your attention. I hope it was useful and interesting.
Any questions for George? Looking around. Questions? One question in the corner.
I have a more like technical question on like the data types, right? So can you just like speak more about the data types? Yeah.
Data types, you mean like this slide, related to this slide?
Like the fields, UINs, that kind of
Yeah, so, okay, just really briefly. Each field element is just a 30-byte number. And verification key is just, well, pretty much also like, I'm not sure if 30 bytes, well, it's more than 32 bytes, I think, but also some bytes, and rest of things are just, like Boolean variables, so like numbers, like regular rate, so it's, yeah, pretty familiar to every developer, I guess. I hope it answers.
Hi, thanks for the presentation. Incredible. Do you have any use case that you can comment, like any use case about the CK app on Mina?
Any use case? Actually, a lot of them. So it's kind of, beyond the scope of this talk. I almost exceeded the time limit, but there is the app directory. Please visit this website. It has, well, I'm not sure how many, but a lot of prototypes mostly, but some things which people are willing to deploy on mainnet immediately after it's deployed. And also, like, we have a use case that is, I think, deployed in production already, which doesn't use on-chain computation, which is like off-chain case. Related to the loyalty program of one company. Anyway, please.
I'm here.
Oh, yeah.
Since the chain is so succinct, how does the block explorer work?
So as I said, full nodes do not need to have the whole history. Block Explorer does have to have the full history, but Block Explorer are not secure from security standpoint and from operational node point. If Block Explorers all die tomorrow, well, the network will continue as nothing happened. Users will be a bit less, involved. But yeah, anyway.
Anyone else? Going once, going twice. Round of applause, please.
Thank you a lot.